Hey there, Sam here. In this video, I'm going to do a review of this Aqueous 12-volt 6-liter water heater. I know it's been a while since my last video. Through the fall onward, I've been busy doing a lot of client van projects, and I just wasn't able to prioritize making videos, but I'm going to try to shift that focus and prioritize getting more videos out this year and getting back to my transit rebuild. So on this van here, I put in this water heater, I did an expansion to the battery bank, added an air conditioner, and did a couple other odds and ends. But it's this water heater that I want to talk about. What I think is cool about this water heater is that it's an electric water heater that runs on 12 volt instead of 120 volts. In the US, I've always found that it's hard to find 12 volt water heaters. But if you want to save power, it's often much more preferable to use a 12 volt water heater, even if it heats the water slower than a high power 120 volt water heater. This water heater in particular is called the Aqueous 6-liter 12 volt water heater, and it's made by a company called Bosch. It's actually an Australian water heater, but there's a few companies that resell it here in the US, and I'll leave some links in the description to where you can order it from. So for a couple quick specs before we dive in deeper, its capacity is 6 liters, or in gallons, that's about a gallon and a half. The size of it and shape are pretty comparable to the Bosch 2.5 gallon 120 volt water heater you see used a lot, but it's just a little bit smaller. The Bosch one is about 14 inches by 14 inches by 14 inches, and this one's about 12 inches by 12 by 12. And with both, you have to account for a little extra room for where the plumbing attaches. Power-wise, this thing has a 160 watt heating element, or for a 12 volt system, that is about 13 amps when it's heating. The first thing I want to do is go ahead and test how long it takes to heat a full tank of water. And from that, then we can estimate how much power it uses to heat one full tank of water. After I finished installing this one, I did some initial testing, and then I winterized this system, drained all the water out. So first thing I need to do is go ahead and fill this back up. Let's go. This tank has a really simple fill port here. Alright, since this system was totally empty, I'm going to go ahead and prime all the cold water lines first to get the air out of this, and then I'll fill up the water heater. So go ahead, turn the pump on. You go open the kitchen faucet. So it should be all filled up now. With any water heater, you never want to have the heater turned on if there's no water in it, because you can burn up the heating element inside. So right now this thing's been switched off. So when I installed the heater here, I have a bypass setup with 3 valves. So I have a valve on the input to the heater, a valve on the output, and then a bypass between the input and output with its own valve. So to fill this, I'm going to go ahead and have the bypass closed. I'll open up the output side so the water can flow, and then I'll open up the input side. And then the heater can start to fill with water, but the other important thing to do is to open the faucet for the sink on the hot side so that all the air that's in here can escape and be purged out. So I'll go ahead and open this and then go open that faucet. So now this thing's full. Before we turn it on and start that heating time test, I wanted to talk about this bypass here on the installation. So there's 2 reasons to add a bypass for your hot water heater. The primary one is that when you're sanitizing a water system in a camper or RV, you usually do that by adding a little bit of bleach into the system, letting that sit, letting that circulate through all the components. You don't want that sanitizing solution to run through water heaters. It's generally bad for the interior of them. And so you want a way to bypass that. So in this case, you would close the valve at the input, the valve at the output, open the bypass, and then you can circulate water through the rest of your system without it going through the water heater. The other time you may want to do this is if you're putting RV antifreeze in to winterize one of these. This water heater can be drained on its own, and so as long as you get all the water out of this, it's not going to have a problem sitting during a freeze, and so there's not a good reason to run the RV antifreeze through it if you can avoid it. So that's why it's nice to have this bypass valve. The front of the water heater here is pretty simple. It just has a power and temperature dial. There's a thermostat inside the heater, and that's what this controls. And so depending on where you have that set, it'll cut the heating element on and off to maintain that set point. So another install note on this: I ran the power over from the fuse panel over to here, and you want a way to switch the heater on and off so that you don't have to run it all the time, can save power when you don't need hot water. So on the other side of this wall, I installed a switch, and the switch doesn't directly switch it, but it works through a relay, and that just keeps the full power that's going through that wiring from passing through the switch. It's good best practice to use a relay when you're switching something like this that is a little bit of a higher power load compared to if you're putting a switch on just a light or a lower current DC appliance. I'll throw a wiring diagram on the screen that shows how this is electrically connected. Okay, let me go ahead, pop over to the other side of this wall and flip that on switch. Okay, so I'm gonna go ahead and start my timer, flip the heater on, and both the power and the heating light turned on. So now we'll let that run, and when the red light turns off, that means it has reached the set temperature on the thermostat and it's fully heated the tank. I'm going to go ahead and let this run while I go tidy my workshop a bit, and then once it finishes, we'll talk about the results and the rest of my review of this water heater. So my test of timing how long it took to heat up the tank ended up taking a lot longer than I expected. So what I ended up doing was timing it at 3 different positions on that heating control or thermostat knob, and for each one I measured how long it took till the thermostat clicked off and then what the temperature was at the faucet. I'll go over those test results and then talk about what I think the pros and cons are of this particular water heater. First though, I wanted to comment on who might want to consider a water heater like this one in their build. I think this water heater or a similar style one is good if you're avoiding propane, but you also aren't going all out with a really high-end heating solution like a Rixon hydronic system, which is also very expensive. When it comes to propane water heaters, it feels like there's a lot of options out there for traditional RVs and campers, but not as many good options that are install friendly in vans, since we have kind of a weirder shell we're working with, and that are also safe to run in an interior enclosed space. Over the last 5 years, lithium batteries have gotten a lot cheaper, and so the trend for camper vans seems to be going with more electric appliances such as induction cooktops and electric water heaters, and skipping that additional fuel source like propane. The one exception to this is usually air heaters, because the gas and diesel air heaters like the S-Bars or similar ones from other brands are a really good option that just work really well. Anyways, so now for the test results. With that thermostat knob set fairly low, it took 56 minutes to heat up, and then when I measured the temperature at the faucet, and go ahead and feel that, okay, getting warm. Not like burning me, but it's pretty warm. It doesn't feel like it's getting any hotter. We're at 99 degrees. Pretty solid 99. So not all that warm. It was only 99 degrees, which is warm, but not really as warm as you want from a water heater. Then, with the knob set to around the 3/4 position, it took 2 hours and 3 minutes for the tank to fully heat, but then when I measured the temperature coming out of the faucet, it was pretty hot to the touch. 120, 129, 130, 135, 136, 137, 140, sorry, 130, yeah, 139, 140, 141, there's steam. Alright, and then we started to cool a little bit. Wow, okay, so in 2 hours we were able to get it to 140, but that's really warm, and if you mix that with some cool water, you're going to extend how long you can get that to last. You could also put a thermostatic mixing valve right at the output to help extend that without doing it at the mixer here, but that's pretty decent. I mean, you certainly have to allow for the extra time for it, but at least it gets there. And just to note, the ambient temperature at the time of that test was about 50 degrees around the outside and the back of the van here. And the initial test I did was I had turned the thermostat valve basically all the way up to the max, and then I backed it off just a little. And I had let that one run, and I didn't think it was ever going to stop. That had been the first test I did. And after about 2 hours, 18 minutes, I kind of gave up and turned it off. And when I measured the water at that point, it was at about 140 degrees. So I found that result kind of interesting. According to the heater's manual, the thermostat set range is supposed to be 30 degrees Celsius to 75 Celsius, which is equivalent to about 86 to 176 degrees Fahrenheit. My conclusion, though, is that the 12-volt heating element in this model seems to have trouble getting past about 140 degrees. And I think that's fine. You just want to know that you shouldn't set the thermostat way into the top end of that zone because it may never be able to reach that temperature and may just continue to run and waste power. So overall, it gets plenty hot, but it takes its time to heat up. It'd be good to turn on when you're driving and you're also getting some charge from the vehicle's alternator, and then you'll have hot water later on when you get where you're going. From a power perspective, I measured the heater was using about 13.5 amps at 13.24 volts. So that equals about 180 watts while heating. 180 watts for 2 hours means we consumed about 360 watt hours of power to heat that tank up to 140 degrees Fahrenheit. Or to give that quantity in amp hours for a 12 volt system, it would be about 28 amp hours. In this van, there's 400 amp hours of battery here in total, and so 28 amp hours would be 7% of that total battery bank capacity. I'm going to compare this heater a lot to the 2.5 gallon Bosch 120 volt heater because they're very similar style water heaters, just one's 12 volt and one's 120 volts. The 2.5 gallon Bosch is rated at 12 amps of current at 120 volts, or 1440 watts. Now, since that's a 120 volt AC water heater, you're going to be running it through your inverter. And depending on what inverter you have, it's probably somewhere between 90 to 95% efficient. So when we calculate that efficiency in, our actual wattage when powering it through the inverter is about 1550 watts. I used 93% efficiency for my calculation there. That Bosch water heater, though, only takes about 20 minutes to heat the full tank of water. And so when we look at that wattage over 20 minutes, we consume about 516 watt hours of power. Or if we're going to put that in amp hours for a 12 volt system, that'd be about 40 amp hours. So comparing the two, we had 40 amp hours versus 28 amp hours, but we also had 2.5 gallons versus 1.5 gallons. So it's a little more power, but it's also heating a little more water. So that was my test data, some runtime numbers and some power consumption numbers. Now I want to talk about where overall I think the pros and cons of this water heater land. The first pro is that this water heater is designed where it can be mounted with your inlet and outlet port facing either the bottom of the heater or flipped around and facing the top. It installs by screwing a mounting bracket to the wall or whatever surface you're mounting to, and then it has notches, and it's got notches both on the top and bottom to allow mounting it in either of those configurations. I think this design makes it really RV friendly because mounting it with your inlet and outlet ports at the bottom makes it easy to drain the water out of this when you need to winterize your camper. For me, that's always been one of the really big drawbacks of the Bosch water heater is that one's not necessarily designed with RVs in mind, and it has to be mounted with the inlet and outlet ports on the top of the heater. And that means if you need to winterize it, you need to drain all the water from it, you basically have to disconnect it and pull the thing out and dump it, which is a lot harder to do than being able to just open a valve here and let the water drain out. For the next pro, I'm going to cut back to a clip when I first started testing this, and I talked about the insulation of the water heater. One thing I noted though is the insulation around the water heater does seem to be pretty good because when I measure the side of it here, I get 66 degrees, which is really just like 2-3 degrees warmer than what's next to it right here. The front right here, that's a little warm. I think that's probably closer to where some of the electronics are. That's 80, but the rest of the heater, 66, 67. So good insulation in it, so that means once it heats that water, it should be keeping it warm. Well, installation-wise, I think this water heater is pretty straightforward to install. No different really than one of the Bosch water heaters in that regard, but it is simpler than a fancier water heater like an IsoTemp, which also has the added feature of looping in the engine coolant of the vehicle to heat the water through heat exchanger while driving, but that comes at the cost of a much more complex install. With this one, you basically have your water connections, which you can do mostly in PEX up to the heater, and then you have your electric connection. And I think the electric connection, even putting it through a switch and a relay, is much simpler and easier to do without mistakes than, say, hooking up propane lines to a propane heater. Speaking of installation, I'm going to add a water system diagram to my website that shows all the plumbing connections for a water system that includes a hot water heater like this one. I'll add a link to that in the video description below. The last pro, which I've already mentioned, is just that this heater runs directly on 12 volt and doesn't need to go through an inverter in order to operate. For a 120 volt AC water heater that's going through the inverter, you can generally get away with a 2000 watt inverter unless you want to be able to run another large appliance at the same time, such as an induction cooktop. If you want to be able to have two large appliances like that going, both turned on, heating at the same time, then you really need to have a system with a 3000 watt inverter and then large enough battery wiring to accommodate that. All doable, it just starts to bring your total cost of your electric system up as well with it. Before I get to the cons, there's one item I wanted to point out, which isn't really a con, just something to be aware of. And that's, since this is an Australian-made water heater, it uses BSP, or British Standard Pipe threads, instead of the common NTP, National Pipe Thread, that is common here in the US. This just means that you need to use a BSP to NPT adapter before connecting to the rest of the plumbing. Now for the cons. This water heater is more expensive than the Bosch 120 volt water heater I've been comparing it to. The Aqueous usually costs about $500 from the resellers in the US, whereas you can get the 2.5 gallon Bosch for about $200. The next and most obvious con is just that slower heating time of this heater. This van in particular doesn't have an indoor shower. This is just to provide hot water to the sink. And so in that use case, I think it's just fine. For vans that do have a full interior shower, then you'll probably want to opt for something that heats the water faster so it has a faster heating recovery rate. So I think that's a good summary of where my thoughts lie about this water heater and a few data points of it in action that you can consider when you're designing your van. Like I said before, there aren't a lot of options for 12 volt water heaters out there, and maybe that's because they're less desirable because of that slower heating time. I still think there's good reasons to consider using one though. In the past, I've come across another water heater, which I think is also from the company OSJ, called the Duetto. And the Duetto is cool because it's a dual 12 volt and 120 volt water heater. That allows you to use the 12 volt element when you're off grid and trying to conserve power, and use the 120 volt element when you have access to shore power. I think that kind of gives you the best of both worlds for an electric water heater, but the problem is that I haven't been able to find a US supplier that's currently selling that one, not for the newer Gen 3 model or the older Gen 2 Duetto. If you have a favorite water heater for your camper or RV, let me and others know in the comments below. Thanks for watching, and I hope this was helpful.